Hello and welcome to Spy Math. This is Mr. Spy, and this will be part 2 of the January 2019 Geometry Regents. Okay, on to question 25. Write equation of a line that is parallel to a line whose equation 3y plus 7 equals 2x and pass through point 26. First, you should rearrange this equation as y, figure out the slope, because parallel lines have the same slope, and use the equation. I'm going to show the answer in both point slope form and slope intercept form because both forms are acceptable. So you first solve for y, so you subtract 7 on both sides, and you get 2x minus 7 equals 3y. Divide by 3. Make sure to divide everything by 3. So you get y equals 2/3 x minus 7/3, meaning your slope of the parallel line is also 2/3 since they have the same slope. In point slope form, plug in the point using opposite sides. So y minus 6 equals 2/3 times x minus 2. Or you could rearrange that equation by adding 6 on both sides and then multiplying by 2/3. Or first multiply by 2/3, get 2/3 x minus 4/3 and add 6. Get 2/3 x plus 14/3. There are other ways of solving this equation, but this is the simplest method of writing a solution using the form of y minus y1 equals m times x minus x1, which is point slope form. On to question 26. Parallelogram ABCD is adjacent to rhombus DFG as shown below, and segment FC intersects segment AGD at point H. So here we have parallelogram ABCD, rhombus DEFG. They tell you this angle is 118, so also angle D is 118. They also tell you that angle AHC is 138 degrees. We want to determine the measure of GFH, which we'll notice is 20 degrees at the end. The way you do this is you first notice that angle B is 118, making angle D 118. Also, angle AHC is 138, making angle DHF also 138 because they're vertical angles. You also could find next angle GHF, because those two angles form a linear pair, making them supplementary. So 180 minus 138 is 42 degrees. Okay. Then, using that this is 118, you can also find angle GDE, because CDG and GDE form another linear pair, making 118 taken away from 180, so 118 minus 180 minus 118 is 62 degrees. If this is 62 degrees, the angle below it, E, corresponds to angle D, making them both 118 degrees because these lines are parallel. In the rhombus, opposite angles are common, so angle E is 118, angle DGF is also 118. Then you know this, the angle we want forms a right triangle with angle GHF and angle HGF. So the sum of those three angles is 118. So you have 180 minus 118 minus 42, because the sum of the triangle is 180 degrees. So you take away the other two angles, you're left with 20 degrees. So the measure of angle GAH is 20 degrees. On to question number 27. Shown in the diagram below, secants line PWR and line PTS are drawn to circle O from external point P. If measure of angle RPS is 35 degrees, the measure of arc RS is 120 degrees, determine and state the measure of WT. WT is arc. So we let measure of arc WT be X. Label our diagram X, 121 degrees, 35 degrees. Now if you have two secants, you take the measure of the larger arc outside minus the smaller arc inside, divided by 2 equals the angle outside. So 121 degrees minus x divided by 2 is 35. Solve for x, multiply both sides by 2. Get 121 minus x equals 70 degrees. Subtract 121 degrees on both sides. Get negative x equals negative 51 degrees. Change to positive. So x equals 51 degrees. And replace your answer where it needs. The measure of arc WT is 51 degrees. On to the next question. On a set of axes below, triangle ABC is graphed with coordinates A, negative 2, 1, B, 3, negative 1, and C, negative 2, negative 4. Triangle Q has the image of triangle ABC with graphed with coordinates Q, negative 5, 2, R, negative 5, 7, and S, negative 8, 2. So you want to figure out a way to transform triangle ABC into QRS. You look at one point A. A went from negative 2 to negative 1. And you want it to rotate 90 degrees counterclockwise about the origin. So you have 1, negative 2. Then you translate up 4 units to get A to match up with Q. And then you reflect over the line x equals negative 2. Mark off where A prime is and where A double prime is. Okay. So 1, 2, 3, 1, 2, 3, and it all matches up. Here is the line x equals negative 2. And if you want to see the full answer, it looks something like that. Okay, on to the next question. Okay, given points A, B, and C, use a compensator to construct point B so that ABCD is a parallelogram. So let's use these 3 points to construct a parallelogram. So to construct the parallelogram, first take your straight edge. Line it up with A. And draw a line from A, B. And then do the same thing from B to C. Okay. Once those 2 lines are drawn, put your compass on point B. Open it to point A. Make a middle mark by A. Scroll up to C. Make a middle mark over here. Then rotate your compass and line up a point B. Open it to point C. Make a mark at point C. Slide it over to A. Make a mark there. Take your ruler. Draw a line from A to where those 2 marks intersect. Put it on C. Draw a line again from C to those 2 marks intersect. Call that point D, and that is how you draw parallelogram ABCD. On to question 30. On the set of axes below, triangle DEF has vertices at the coordinates D, 1, negative 1, E, 3, 4, F, 4, 2, and point G as coordinates 3, 1. Owen claims the median from point E must pass through point G. Is Owen correct? Explain why Owen is not correct. You figured it out by calculating the midpoint of DF, because G has to be at the midpoint if it's a median. So the midpoint formula is x2 plus x1 divided by 2. y2 plus y1 divided by 2. You figure out the midpoint, it's 2.5 and a half. not 3, 1 as G is drawn. So medians must pass through the midpoint. Therefore, point G is not midpoint of the F. So EF is not the median to side DF. You have to make sure to specify that it's not the median to side DF, because every side of a triangle can have a median. So remember, Owen is incorrect. On to the final question of this part. A walking path at a local park is modeled on the grid below. Length of each grid square is 10 feet. The town needs to submit paper to pave the walking path. Determine and state to nearest square foot the area of the walking path. So you count the rectangular region. You have 9 rectangles below, 9 rectangles above. That's a total of 18 rectangles. Each rectangle is 10 units, so there's 118 square feet in the rectangular region. And if you take this semicircular region and this semicircular region together, get a whole circle. The inner radius is 20. The complete radius of the circle is 30. To find the area of the circle, you take the outer circle, which is 30 squared pi, minus the inner circle, which is 20 squared pi, which is 900 pi minus 400 pi, which is approximately 1,570.8 square feet. You add that to the 180 from the rectangular region, and you round your answers to the nearest whole number, which is 1,751 square feet. That is the complete Jan 2019 Regents. There are 5 other videos in this series. If you'd like me to cover any other topic in high school math, from Algebra 1, Geometry, Algebra 2, AP Calculus, AP Statistics, SAT topics, or any college level math topic, please leave a comment below. Like this video. This is Mr. Spy, signing off.